Hello everybody, we're talking about solving systems of equations. We're going to talk about two methods now. This is graphing and substitution. And the next day we'll talk about elimination. So kind of looking at those two right now. There are other methods like matrix methods, but we won't get into those until Algebra 2. Okay, solving systems of equations. First we're going to look at solving them by graphing. So we want to find basically what a solution is a value that makes the statement true. But here, since we have a system, we want to make both statements true. So solution makes both statements true. Okay, underline both. Okay, so what are some values that make the first statement true? Well, it happens to be a whole bunch of ordered pairs that land on a line, right? We've talked about this before. So value of x equals 0, y would equal 0, right? So that's one ordered pair that works. If x equals 1, then y equals 2, right? I could make a table of values, right? X and y. So 0, 1, 2. So I got 0. Then y would be 2. When x is equal to 2, then y is equal to 4. And you can kind of see the pattern here. So when x is equal to 1, y is equal to 2. And when x is equal to 2, y is equal to 4. And it makes a line. And I could pick the halfway points, and it would give me a point there. But it's a whole bunch of ordered pairs that lie on this line, right? So all of these ordered pairs make the statement true. So 0, 0 makes the statement true. 1, 2 makes a statement true, 2, 4 makes a statement true, and 3, 6, and so on. Okay, so that makes the first statement true. What about the second one? So I need to find another list of ordered pairs that make that true. So when x is equal to 0, y is equal to 1. When x is equal to 1, y is equal to 2. When x is equal to 2, y is equal to 3. So each time it's adding 1, right? It's adding 1 to the number. That's what this equation tells me. So when x is equal to 0, y is equal to 1. So that ordered pair is true. And then when x is equal to 1, y is equal to 2, which is right there. And when x is equal to 2, y is equal to 3, right there. So it's going to be all of these ordered pairs going like that. Okay, so you want to find a value for x and for y that make both equations true. Well, I can see in the table right here that 1 and 2 are on both lists, right? And you can see on the graph that 1, 2 is that intersection point between those two lines, right? So that's what a solution is. A solution is an intersection point that shows where the lines cross, right? Because this is the value of y, and this is the value of x, and they happen to be the same for both lines. So these ordered pairs that are going along here, well, these ordered pairs all make this line true, but they don't make that line true, right? So let's just try, for example, 2, 4, right, is not going to be a solution to this second equation. It would only be a solution to the first equation. So 4 for y and 2 for x. Is this true? No, it's not. See, 4 is not equal to 3. So that point does not make this equation true. But this point, 1, 2, would, right? So 2 equals 1 plus 1. Yeah, that's true. And then it also makes the other equation true. So 2 equals 2 times 1. Yeah, it makes both of them true at the same time. So that is a solution to the system of equations. And you can find solutions by graphing. So any old graph, if I see something like this and like this, all I have to do is find that intersection point. It gives me a good estimate for the solution. Now, it isn't usually the most accurate way because it could be difficult to see down to the fraction level exactly where that intersection point is at. But it can give you a good rough estimate of what the solution is. Okay. To get a more accurate solution and to be really precise with it, you want to use the substitution method or the elimination method, or one of the other more algebraic centered methods. So substitution method just means I'm going to substitute into the other equation. So let's look at these two. So if I see here that y is equal to 2x, well that means that everything on this side of the equation equals this side of the equation. So these two expressions can be interchanged with each other, right? It's just like if I had 3 is equal to, I don't know, 9 divided by 3, right? So I could substitute 9 divided by 3 for 3, or I could substitute it the other way, right? So these two things are equivalent to each other. Well, these two things are equivalent to each other, so wherever I see a y, I can just put in a 2x instead, and it would still be a true statement, right? So I'm going to do that. I'm going to substitute 2x for y in the second equation, and then I get this equation, right? Now I can solve this just for x, right? Using my equation solving method. So I'm going to subtract x from both sides. I get x equals 1. Okay, so that's the x value that makes the statement true, and I just substitute into either equation. I would find out that y would have to equal, right, if I put in 1 here, I get y equals 2, would be the y value that makes the statement true. And to check your answer, you can plug it into the second equation and see if it also makes a true statement. That's just a way to check, right? 1 plus 1 is 2, and y equals, so 2 equals 2 checks out. So I have checked my answer with the substitution method. Okay, so substitution method, the steps to do that is basically solve one equation for one of the variables, then substitute into the other equation, and solve for the one variable. Now that you have a solution for one variable, you substitute back into either equation and find the other variable. Okay, so that's it. That's the process. Is you solve one equation for one variable, substitute that expression into the other equation and solve for one variable, substitute back into either equation and find the other variable. Now give your two variables as an ordered pair, x and y, or whether it's p and q, or I don't know, any old letters, right? N and m. So that's how you do the substitution method and the graphing and solve by graphing method.